This is your guide to solving linear equations where the unknown appears on both sides of the equation. So here's an example. In order to solve equations like this, we first need to eliminate one of the letters. So by that, we need to make it so that the letter, the unknown, only appears on one side of the equation. The easiest way of doing that is actually to get rid of, or at least to move, the smallest collection of letters. So here we've got 5y on the left hand side of the equals and 2y on the right hand side. I would always start off by trying to get rid of the smallest number of y's. So in this case I'm going to take 2y from both sides of the equals. Got to do the same to both sides, otherwise it will no longer balance. If I take the 2y off this side, we're left with 27. If I take 2 of the y's off this side, we're left with 3y plus 3. This now looks like a normal linear equation. So here we need to start working and doing the inverse of whatever it has next to the y. So here the opposite of add 3 would be take away 3. So I'd take away 3 from 27. Taking 3 from this left hand side cancels out with the add 3, leaving us 3y. We would then have to divide by 3, being the opposite of times 3, giving us the 8 on that side, cancelling out the times 3, so we get y equals 8. Same idea for the next question. You would just be asked to solve. So to do this, we look at which side has the least number of u's. It's 3u, so that is what we are going to take away. If I take 3u off this side, it leaves me with 31. If I take 3u off this side, it gives me 5u minus 9. I then need to start looking and doing the opposite, or the inverse. The inverse of take away 9 is add 9, so that will give me 40 on the right hand side. And on the left, the minus 9 and add 9 cancel each other out, leaving us just 5u. Opposite of times 5 is divide by 5, so we get 8 on the right and u on the left. So u equals 8. The next example starts off slightly different. We've got 9g on this side, 9q should I say, and minus 3q on this side. Well, in order to change this, we'd have to do the opposite, try and get rid of this minus 3q. So for this one, we are going to add 3q onto both sides. Remember, anytime you do the opposite, it cancels it out. So if I add 3q here, it cancels out this minus 3q to leave us 40. But I've got to do the same to both sides. So 9q, add 3q, that gives us 12q plus 4. The opposite of add 4 is take away 4, giving us 36 on the right and 12q on the left. We then need to do divide by 12 to get rid of the times 12. 36 divided by 12 is 3. Divide by 12 on this side gives us q. Same again for this example. 4p and 7p. Well, this time 4p is smaller, so I'm going to take 4p away from both sides. Always try and move the smaller of the two. It normally makes it easier later on. If I take 4p off this side, I'm left with 3p plus 7. And if I take the 4p off this left hand side, I'm left with minus 5. Don't forget to keep that minus there because that relates to the 5. At this point I now need to start doing the opposite, the inverse of whatever has happened to the p. So step number 1 is the opposite of add 7, which is take away 7. That cancels out on this side to leave me just 3p. Minus 5, take away another 7, gives us minus 12. Then to get p on its own, I need to divide by 3, making that p. And on the left hand side, minus 12 divided by 3 is minus 4. The convention then normally would be to switch these round so that the unknown is on the left, so p is equal to minus 4.